Hello, can you hear me? Can you hear me?
Yes.
Okay, how are you today?
Alrighty.
So last week, I introduced you to hypothesis testing. Particularly, we covered how to state hypothesis. Today, we'll finish hypothesis testing. But before we do that, let me show you what is due this week. Okay. So for my announcement, you see that we have week 16. This is week 16. We finished chapter 9, then the classwork and homework 9. So homework 9 is due on the May 14th. Classwork is due tonight. So we have only 2 assignments this week. Next week will be our last week. After next week, we won't have any class anymore. So next week, I will try and I'll be in the campus. So if you have any other questions, you can ask. I've seen that so many of you have finished their project. That is very good. Let us begin now. All right. Like I say, when I introduced you to hypothesis testing last week, I showed you how to state hypothesis. Now we'll focus on the actual work of testing hypothesis, starting from the few terms. So the terms we use in hypothesis testing. First one is the significance level. We have met significance level before. Please, if you want to ask question here. Don't send me text. Now, the significance level is we did this when we met it before when we were doing a confidence interval. It is the same thing. I said that this time for confidence interval we are using 2 sides always, the left side and the right side. But in this hypothesis testing, sometimes we can have 1 tail test and 2 tail tests. It happens sometimes, depending on the way the equation is structured. Now, the significance level simply means the probability of committing type 1 error. And when we say type 1 error, it means the probability of rejecting a correct null hypothesis. So you can see it from here. The probability of type 1 error equals alpha, which is our significance level. Yeah, the most common significance level we use in statistics, especially at this level, are 95% significance level. That means if you're using 95% significance level, that means your probability of rejecting a correct null hypothesis should be 5% only. So that means your alpha will be 0.05. If you're using 99%, then it will be alpha 0.01. If you're using 90%, you're going to be, that means your chance of being wrong or rejecting a correct null hypothesis is 10%. So your alpha will be 0.01. Now, another thing is critical region. Critical region and critical value, they are related. Basically, they tell you the rejection region, in which case, if your answer falls in that region, you reject null hypothesis. Otherwise, you don't reject it. Now, who is Fatima Nebia? This person is not in my class. Who is Fatima Nebu? Hello? All right. Now, who is Fatima Nebi? Can you identify yourself? Fatima Nebi. Yeah. That means I have to take her out. Yeah. And let me see her here. All right, all right. Okay. Anyway, let's continue. I didn't see her here anymore. Now, so the critical region is just the rejection region. If your answer falls in that region, you reject it. Then critical value is the cutoff value. It demarcates the critical region from the non-critical region. I will show you the diagram. Now we have two-tailed tests. A two-tailed test is used if the deviation of the estimated parameter is in either direction. Like here, you can see the diagram here. So it can be so this is the critical region. Let me make this into be okay. You can see the critical region right here. If you answer for in this region on the right side, you reject. If you false here, you reject. But if it doesn't, if you fall, this is the acceptance region. If you false here, don't reject. Okay. So now, because it had two of them, left side and right side, we say that it is a two-tailed test. Now, one-tailed test, we have two types of one-tailed test. We have the left-tailed test, whereby the critical region is on one side. On the right-tailed test, the critical region is on the right side. Excuse me. Now, having given you this background information, you can now begin the work of testing hypothesis. Any question before I start that? Any question? Hello, any question for me before we start testing hypothesis? Okay,
No.
since there is no question, we can begin. Now, we will start with the z-test for the mean. These are the working rules for z-tests. State the hypothesis and identify the claim. So first of all, you state your hypothesis, then identify your claim. Next thing is to find the critical values using the appropriate table. I have already shown you some of those tables. I believe I told you to print them out because we'll be using them from now on. I uploaded them for you in your class, the 5 section of your class, statistical value. Okay. So you can see a list of them here. So we're using this one. Okay, good. We'll be using the normal distribution. Go 5. Okay, good. So now close this. Okay. All right. Okay. I'm gonna share this. Good. So you state the hypothesis and identify your claim. Then find the critical value from the appropriate test. Compute the test value. Make decision to reject or not to reject the hypothesis. And summarize the result. Now, this is for the traditional method of doing z-test. Now, how do you make the decision to reject or not reject my hypothesis? We do that by following this criteria here. See, it's called decision criteria. It says, reject the null hypothesis if and only if the calculated value is equal to or it is greater than the critical value. So you get a critical value, get a calculated value, you compare them. If they are equal to the critical value, you reject my hypothesis. If they are greater than the critical value, you reject. But if they are less than the critical value, do not reject my hypothesis. That is the criteria. Okay. Now, the test statistics we use when testing not an alternative hypothesis, the test statistics we use, okay, is as follows. The test statistics is Z equals X bar minus mean divided by standard deviation over root N, where the X bar is the sample mean, mu is the population mean, delta is population standard deviation, and N is sample size. I wonder why it's doing this. Okay, is it because I increase it? Okay, let me open it again. I gotta open this again because it will be giving us trouble if I don't. Open again. Open a new one. Hypothesis testing. Good. For some reason, if I come to this site, it will not allow us to go in. Okay. Make sure you are seeing this. Okay, good. So our first test comes as follows. It says, I gotta go up to put this number in. My goodness. Maybe I should use the other one. Just give me 1 minute. Let me get the other one. Next, let me use the one on desktop. Okay. Let me use desktop. Let me use this one. See if they can do the same thing. If the same thing, then you have to stick with it. Yeah. That's better. It's tempting. Okay. I see. All right, let's begin. I think there's nothing much I can do about it. All right. Yeah. I think we are ready. Okay. Now let's look at our first question. We're going to be following these simple rules. Simple rules, which includes to state a hypothesis and identify the claim. First example says, just this example should be enough to illustrate that. It says, a researcher reports that the average annual salary of assistant professors in 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260. At alpha 0.05, there's the claim that the assistant professors earned more than 42,000 a year in 1997. The standard deviation of the population is 5,230. So to solve this, we move to remember the rules. The rule says, state the hypothesis and identify the claim, then find a critical value. Okay. So we come here and then now the solution will say, let's state the hypothesis. Now, this reports, this researcher claimed that the average salary of assistant professors in 1997 is means equal. So that means HO, we're going to have HO and H1. This is the first thing. And we can only use equal sign in the null hypothesis. So we put our mean, we'll insert the mean. The mean equals the $42,000. $42,000. Then alternative is opposite of the mean. We say that average salary is more than. Oh, so my mistake. We say that it is more than. It's more than, you see here, say is more than. So that means greater than. We can use greater than only in the alternative hypothesis. So I'm gonna put that one first. More than. So the average salary is, that is mean, is more than 42,000. Okay, $42,000. That is the claim that he's saying. It's more than $42,000. Then the opposite, not an alternative hypothesis, they are always the opposite of each other. So the opposite will be less than, but we cannot use less than in the null hypothesis. So we're gonna use less than or equal to. Okay. 42,000. So now the alpha is 0.05. Okay. We have our alpha 0.05. I can put it from here. The alpha 0.05 equals 0.05. That's it for alpha. I'll put it again. Alpha. So now we have stated the hypothesis, we have identified the claim. Now let us find the critical value. Okay. The critical value from the table of normal distribution. If you draw the charts, you're gonna be in this form. Let me put it this way. Okay, let me get the critical value first of all. So the critical value, because this is a one-tailed test, because it says greater than, so you're gonna be a right-tailed test. I will show you how the right-tailed test looks like after getting the critical value. Critical value is, remember I told you from the chart we are using before that whenever it's on the tail, you subtract from 0.5. So to get the critical value, since we are going to be using this table, this type of table, right? This is not the cumulative one. This one is not cumulative. So since we are going to be using it, we'll get our critical value this way. 0.5 minus 0.05, and that will give us. I'll get it from the calculator. 0.5 minus 0.05. Get 0.4500 is 0.4500. 0.4500. So why do we add 2 zeros to that? Because when you look at this table, all the figures here is that there are 4 digits. So to complete it 4 digits, we added that 2 zeros. Now we can get the critical value by looking for 0.4500 from the table. You come here, 4500, start looking for it here. We found 2 numbers, 4495 and 4505. Both of them are equally close, because if you ignore the decimal point and do 4505, you do 4505 minus 4500. You get 5 points. And if you do it for the other number, since we didn't find the exact value of 4500, we find values that are close to it. If you try for this one, 4495. 4495. So we have 4500 minus 4495. You see, it's 5 points. So they are equally close to 4500. So when this happens, what you're gonna do is to choose the one that is bigger than the 2, which is this one here. So once you do that, you follow it to the left. You see 1.6. Follow it up 5. So 1.65 is the critical value. 1.65. Okay. 1.65. Okay, man, this ain't gonna go down. Give me 1 minute. I'm gonna bring this down. Okay. 1.65. Okay, 1.65. It's critical value. Now I'm going to show you how it will look like. So I'm going to have 0, 1.65, and then you can draw your line. Okay. Get the okay. Then you put the center line, which is the mean, and then then I'm gonna figure out a way to put them back because this will keep going out. It won't allow us to put the cursor in. So I'm gonna put it back in from here. So now we can now share the numbers to show you this is 1.65 is located here. And then this is it. That would tell you the critical region is on the right side, as you can see. The place I'm shading now represents the critical region. Okay. So if your answer falls in this critical region, that means you reject one hypothesis. If it doesn't fall on it, you don't reject it. So if you fall on it, okay. Anyway, so you can see that it's on the right side, so we call it the right tail test. So that means now, if our answer is bigger than this, we reject one hypothesis. If our answer is equal to this number, which is the critical value, we reject it. Otherwise, we don't reject it. So now that we have stated our hypothesis, we identify our claim, we have our critical value, we are now ready to run the test. Remember that for this test, let me write down, say that there is such a report that the average annual salary is for more than 42,000. So the population mean, let me write this down, and then I'll put them in. The population mean mu is 42,000. And then they collected a sample of 30 assistant professors. So M is 30. And further, the mean salary is give me 1 minute. And the mean salary is 43,000. So X bar is 43,260. Sorry, 260. And the standard deviation is 5,230. Standard deviation is 5,230. So let us now run the test. Since we have all our odd numbers, I will put them all in, and then we can go and then get our z-test statistic. So the mean is starting the mean is equals 42,000 sample of 30 assistant professor were sample 30 of that sample mean. We can't get X bar from this workbook, so we're gonna get it from the other workbook and then put it here. So I'm gonna take you to that workbook, which is this one here, because this one will not allow us to get it. It's found here. I didn't open it. I gotta open another workbook. Okay. So open it here. Then show it to you. So for this workbook, we have insert equation. So we have X bar, which is the this one. So now here you can get the character that have X bar is 43,260, which we can now copy and put it on our main workbook. Okay. Okay, that's fine here. So now the standard deviation is giving us delta equals 5,230. So to do the test statistics, we're going to use the formula for the test for the mean. I'm going to write it on the other workbook so that we can copy them here. But in the meantime, let me correct this. It's delta, not triangle. Delta. So you're going to be S bar minus mean over standard deviation over root n. So I'm going to do it, put it on the other workbook so you can see how it is written. It's written as Z test Z equals, we have X bar, which is the sample mean, minus population mean, which is this one here, population mean, okay, is somewhere here, right here, divided by standard deviation of delta over the square root of n. And so I'm going to make it big so that you can see it. All right, that's the formula right there for testing hypothesis. I mean, for Z test for the mean. Equal. So I have written all the values for this. You can see them from here, from our main workbook. You see the values for mu, n, sample mean, standard deviation. So we just plug them in the formula. Let me write them down and plug them in, and then we can get our test statistic. Then after that, we can compare to see if to reject or not to reject. Z equals X bar minus mean. Oh, so I will have it already. X bar is 43,260, and the mean is 42,000. Some population mean divided by standard deviation of 5,230 divided by root n, which is root 30. So I'm going to go over there and put it in. Okay, so you can see that. So now we have them here. We can now put numbers in. Okay. So you have sample mean. Make sure you're seeing this. Okay. Sample mean is 43,260 minus population mean of 42,000 divided by standard deviation over square root of n, standard deviation of 5,230 square root of n. Our n is 30. So we can go and plug this in a calculator and get our answer. Then we can transfer it to the other side. Okay. So let's get it on the calculator. Our calculator is right here. So you have X bar, which is 43,000, okay, 43,260 minus 42,000 divided by standard deviation of 5230 divided by square root of n. Our n is started 1.3195610. So basically approximately 1.32. 1.32. So we can go and put our answer in the workbook and then transfer it to the main workbook. 1.32. So we transfer this here to the main workbook. So we can complete the question. Okay. All right. Transfer it on here. See? Now we're ready to compare the equation. So we have remember, we have stated the hypothesis. We have gotten our critical value to be 1.65. We have gotten our test statistics to 1.32. Now let us make decision. The critical value, maybe I should bring it up. The critical value, oh, excuse me, equals, we got it as 1.65. 1.65. Okay. Calculated value. Calculated. Remember the critical value is represented by, because it's one test, by Z alpha. Z alpha. Okay. Z alpha. And alpha is right here. Now, if it is 2 10, we use alpha over 2. But this is 1 10. Then calculated value. Calculated Z, which is our test statistics. Calculated Z equals our answer, which is our answer for that question is 1.32. Now we compare them because the calculated Z is less than the critical value. We don't reject null hypothesis. Do not reject null hypothesis. Reject null hypothesis. Do not reject null hypothesis. Null hypothesis. Because the calculated Z is less than the critical value. If it is greater than the critical value, you reject. For instance, it's less than critical value, you do not reject. So this means that remember, this is the decision. This is our decision. Okay. I'll make it bold so you can see. Okay. So now remember, if our hypothesis that no hypothesis is that the average salary, which is me, is less than 42,000. Is less than or equal to 42,000. But the claim is that it is greater than 42,000. So, but it says here, do not reject no hypothesis. So we are not rejecting the no hypothesis. That means this claim is incorrect. So that's our final conclusion. So we do not reject no hypothesis. So our conclusion now becomes our conclusion. Okay, there is insufficient evidence to support the claim. And what is the claim? The claim was that the average salary of assistant professors in 1997 is more than 42,000. So there's insufficient evidence for the claim that the average salary of assistant professors okay, in 1997 is more than $42,000. So that is how we test hypothesis, ladies and gentlemen. Now, suppose our answer is something bigger than the. Let's say that our answer is 1.8, which is bigger than this. In that case, we reject null hypothesis, and then that means the claim is correct. We can then say that there is sufficient evidence to support the claim that the average salary of assistant professors in 1997 is more than 2,000. Any question for this? Any question? Hello, can you hear me? Any question? Can you hear me? Hello, scholars?
Yes, we can hear you.
Can you hear me? Do you have any question for me before I go to the next one?
No questions.
Okay. All right. So now you can try this one as a practice. Let us go to the second method of testing hypothesis. The second method, we use what we call the p-value method. P-value simply means the probability value. In that case, what you do is you state the hypothesis and identify the claim, and again, you compute the test value. Then after that, you find the p-value, then make a decision. So your decision will be the same as if you are using the traditional method. So that's simply the same thing. Then you summarize the results. Now, if you're using the p-value method, this is how you make your decision criteria. If the p-value is less than or equal to alpha, then you reject the null hypothesis. But if the p-value is greater than alpha, do not reject null hypothesis. So let's try an example using this p-value method. You say that a researcher wishes to test the claim that the average age of lifeguards in Ocean City is greater than 24 years. So she selects a sample of 36 lifeguards and find that the mean of the sample to be 24.7 years. Now, the standard deviation of the population is 2 years. Is there evidence to support this claim at alpha 0.05? Use p-value method. So in this case, you don't need to calculate the critical value at all. Just go right into it. So that, but the first thing is to, like before, is to state null hypothesis and the alternative hypothesis. I'm going to put both of them, HO and H1. I don't know why they are bold, but I'm going to change it to unbold it. So you say that a researcher wishes to tell the claim that the average age of lifeguard in Ocean City is greater than 24 years. You can only use greater than in the alternative hypothesis. So we're going to put it there, the average age, it says greater than 24 years. So I use greater than 24 years. Then the alternative, then not an alternative, they always say the opposite of what the other one is saying. So this one is saying greater than. The other one, the law will now say less than. However, the problem is that we cannot use the symbol less than in the null hypothesis. So we can only use the less than or equal to symbol. That means we're going to use this less than or equal to symbol. So that means is less than or equal to 24 years. 24 years. So then our alpha is 0.05. That's right there. 0.05. I can make it become more like the other one. Okay. If you are seeing this. Okay. Now, next thing is to find the calculate the p-value. So what you're gonna do is to do the z test, the z. So to do that, to find the test statistic, use to get the p-value. Okay. This one does not require critical value because this is the p-value method. So again, mean, now let's use the values we'll put in the equation. Mean is 24 years. Standard deviation, okay, equals half is 2 years. 2 years. Sample size n equals 36 lifeguards. They selected 36 lifeguards. And the sample mean, we cannot get the character X bar here, so I'm going to get it from the other workbook. So I'll take you there to get our X bar. So our X bar was, I think it is 23 years. Let me see. X bar, okay, it says 24.7 years. 24.7 years. So it'll be 24.7 years. 24.7. So I'm gonna copy this. Okay. Put it on that workbook. 24.7 years. Now, we're ready to plug it into the formula. Remember the formula, let me write this down before we can plug it into the formula. Formula is z, x bar minus mean or standard deviation divided by root n. And then we have our x bar minus mean, that is the formula right there, x bar minus mean divided by standard deviation of 2 over square root of 36. So, yeah. Now, I'll take you there so you can see, get it, put it on this workbook. So that z equals x bar, which is this, minus mean, you have mean, okay, divided by standard deviation over root n, standard deviation by square root of n, excuse me, okay, which is we have x bar. If you look at our question, you see where I listed them. S bar is 24.7, mean is 24. So I'm going to go and then standard deviation is 2 and n is 36. So we go and put them in. We have S bar 24.7 minus 24 divided by standard deviation of 2, okay, over the square root of 36. That 36 of lifeguards are selected. So putting this together, we're gonna put this on the calculator. Okay, let's go to the calculator and put this in. I got 24.7 minus 24 divided by standard deviation of 2, okay, by square root of 36. 2.10 basically. 2.10. Write this down. 2.10. So I will go and put 2.10 into the formula to our calculation, then transfer it to our main workbook. Copy this. Go to our main workbook and put our results. See? Now we are ready to make our decision. To make our decision, we find the p-value. So to get the p-value, remember, we need to draw our charts. Our charts. Okay, where are we? 2.0 should be here. And put 2.0 here. Oh, excuse me. So we have 0 here. Let's say this is 2.0. 2.10, sorry, 2.10. Now we can put our chart here. Make sure you're seeing this. I'll put our charts. Put this right there. Then, draw our Z curve. I think I didn't do it well. I'm going to delete it. So through our insert, draw our Z curve. Okay. Now okay, do this. Then so we can get our p-value. You can see where our 2 is. When I say 2, I mean 2.1 or 2. And I can shed the can put our center line, which is present the mean. This line, then this is our 2.0 here. These are the tail. And when it's at the tail, remember what I told you. You subtract your answer from 0.1. Okay. So the tail. Sorry, from 0.5, not from 0.1. So p-value. All right. I get this. So it is at the tail of the distribution. Okay. All right. Okay, so that our p-value, you can see, like I say, is at the right tail. So the p-value now become p-value. Since we're using this table, this type of table, remember, we're using this type of table. Okay. So you're gonna get it is not cumulative. If you're using the cumulative table, that means you're gonna use a different rule. This one is not cumulative, so we're gonna use our p-value in that case. If you're using this table, you're gonna become p-value now becomes p-value. Okay, value equals 0.5. If you're using that type of table, if it falls on the tail, you subtract the result from 0.5. Why? Because half of this is 0.5 and the other half is 0.5. So let's find 2.10 on the table. 2.1, that's 0. See the 0 right here. See the 0. So 2.1 under 0 is 0.4821. 0.4821. Right there. 0.4821. Okay. That's a right to have 0.4821. 0.4821. That gives us the p-value I. When we let me make it distance a little bit smaller so that space can contain it. Okay. So now, so 0.500 minus that. You can get that from the calculator. Okay. So I said 0.5000 minus 0.4821. 0.0179. 0.0179. So let me write that. 0.0179. Okay. Now that's a p-value. 0.0179. So now we have our, remember we have stated our hypothesis. We got our alpha. We got our z test. Now we got our p-value. To make the decision, we compared our p-value to the alpha. So it means that comparison means alpha equals to make decision. Okay. Alpha equals that. P-value, the p-value equals our p-value is 0. You can see right here 0. I'm gonna copy it from here. 0. Okay. This. So I'm gonna make it them all to have the same size so that to be uniform. Let me just make it 14 and bold this. So now, remember the criteria for not to accept or to accept. See, the criteria is this. If the p-value is less than or equal to alpha, reject the null hypothesis. If the p-value is greater than alpha, do not reject null hypothesis. So here, the p-value is less than 0.0179 is less than 0.05. So it's less than the alpha. So we reject the null hypothesis because the p-value is less than alpha of 0.05. It's less than alpha of 0.05, you know. So we reject null hypothesis, which means that remember it says a researcher wishes to tell the claim that the average age of lifeguard efficiency is greater than. So this is the claim right here, greater than. It's a claim. So if we reject the null hypothesis, that means we are accepting this, which means that the claim is correct. To since the p-value is less than alpha, then we reject the null hypothesis. Then we can now make our conclusion. Again, since we are rejecting the null hypothesis, that means the claim is correct. So that the claim that the average lifespan of patients of lifeguards, the average age of lifeguards in ocean cities is greater than 24 years is correct. So you can say that there is sufficient evidence to support the claim that the average age of lifeguards, I should have that's I'm gonna put it right there. I've already copied it. I forgot. Make it bold. Okay. Okay, let me lower the yep, make this one bold. So there's sufficient evidence for the that the average age of lifeguard is greater than 24 years. So that is it. That is the how to do this using the p-value method. Any question, class? Yeah, so no question. Then in that case, you can try this as a practice. Now, before I leave, I want to show you something. If this is, remember, this is right tail test. If this is two tail test, we have this one, this place will be equal, and this place will be non-equal, not equal. In that case, you get the p-value. To get the correct p-value, first of all, you get the p-value itself, then multiply the answer by 2. That will give you the actual p-value to use. So if it's a two-tail test, multiply your p-value by 2, and then use it to make your decision. Now, which leads us to test of hypothesis for small samples. Yes, when the sample size is small, we do the t-test. Z-test is done when the sample size is statistically large enough. For example, if you look at the first example we did with the traditional method, the sample size is 30, which in statistics is statistically large enough, as long as they are selected randomly. And the second example I did for the p-value method, the sample size is 36 lifeguards. So sometimes the sample size would be small. In that case, use the t-test. It's basically the same thing, except that we use the t-table, t-distribution, the student t-distribution table. That means for t-test, we'll not be using this one. We'll be using this table here, the table C, which is the student t-distribution, okay? Which is based on degree of freedom. I showed you how to get those last week. Now, actually, I showed you we were doing confidence interval. Yeah, that was last week. And leaving last 2 weeks. Now, so for the small sample, we use the t-distribution and we do the t-test. Okay. Now, so when we say that sample size is small, we're talking about less than 30. As you can see, and the formula we'll be using now, because it will no longer be Z here. It's gonna be T. T, and then now it will be T minus. I will be using the sample mean and sample standard deviation, not the population standard deviation. And of course, you know that for the t distribution, the degree of freedom is always equal to n minus 1. Let us try this example. Example says, a job placement director. No, excuse me. Say a job placement director claimed that the average starting salary for nurses in 2000 is 24,000. A sample of 10 nurses salaries have been of 23,450 and a standard deviation of $400. Is there enough evidence to reject the director's claim? Now, you can see that the sample size is small, only 10 nurses. So that means we're going to use the t distribution. Solution. Again, remember the beginning is to state null and alternative hypothesis. That's the first thing you do. The null and alternative hypothesis. State that. Okay. Let's see. So now, a job placement director claimed that the average starting salary for nurses is $2,000. So in year 2000 is 24,000. That is his claim. Say is means equal. So that means, and we can use equal in the null hypothesis. So we can put the mean equal, and put mean equal to 24,000, that is the claim. And that is the claim. The alternative hypothesis are now going to be opposite of that. That means mean is not equal to that. Mean is not equal to 24,000. And our alpha, of course, is 0.05. We can use it. It doesn't have to be 0.05. It can be 0.01, 0.02, 0.10. It's still the same. I mean, it's not. The best way to put it is that yeah, it depends on the significance level. That's the best way to put it. Here we have the alpha is 0.05. Yeah. Maybe we can use alpha 0.1. Let's use 0.10 then. It's clear. Just that means 90% significant level. Alpha 0.10 doesn't matter to us. Okay. Now we can now run the test, but first of all, they get a critical value. Now, critical value, remember this is a tail. This one is 2 tail test. Anytime you fall on the tail, remember, if I fall on the tail, now we are using T distribution. So it's based on sample. So N equals how many of them? 10 losses. So the degree of freedom, DF. I showed you how to get this when we last week and the last 2 weeks, how to find values from the student T distribution table. The degree of freedom is always N minus 1, which means 10 minus 1, and that gives us 9. So I'm gonna this is too bold, so I'm gonna make it 14. Does anybody have a question? I think I have a word. Somebody say something. If I have a question, please always ask. So our critical value, but because now it is 2 tails and it's T distribution, we're gonna use T alpha over 2. If it is only 1 tail, we just use T alpha. But this one is 2 tails, so it's gonna be T alpha over 2. Now we get that from the table under 9 degrees of freedom. We go to our table. Since it's 2 tails, this is DF, degree of freedom. 2 tails use A double prime. If it is 1 tail, use this one A prime. Okay. Now, so the degree of freedom is 9 degrees of freedom, and for alpha our alpha is 0.10. You can see right here 0.10 under 9 degrees of freedom. So you're gonna go to 0.10. Since it's 2 tail, use this one. 0.10 is right here. It's right here. So under 9 degrees, this is 9 degrees of freedom. So you follow it to go under 0.10. You can see that's 0.10 with 9 degrees of freedom. Okay. So 1.833. Write it down. 1.833. Okay. So I'm gonna go there and put it in 1.833. 1.833. So now we are ready to run our test since we have still our hypothesis and we have identified our claim and we have found our critical value. Let us write down the numbers. Mean equal, this one is mean equals 24,000. That's the population mean. So for this nurses, say that he collected a sample of 10 nurses. N equals 10, and that for some sample of 10 nurses, the sample mean, sample salaries, mean salary is 23,250. So I'm going to write this down. N is 10 nurses. Mu is 24,000. X bar, which is sample mean, is 23,450. Sample standard deviation is S. Anyway, let's go and put, because I can't get the character for S bar here, so I'm going to get it from the other workbook. So I have put it right here. So I'm gonna get S bar equals 23,450. Okay, so I'm gonna copy it and then paste it here in the right place. 23,450. See, then standard deviation. Now, because we are using the sample of 10 nurses, so you have a sample of S. Sample standard deviation is $400, so S is $400. So that our S equals $400. So in that case, to run the test, we do the T test. Now the formula is T. I'm going to write it on the board on the screen. Just give me a minute. X bar minus mean divided by sample standard deviation over root n, and then we can plug our numbers. So since I can't get it on that side, let me put the formula from here. T test T equals the same X bar okay, minus the mean, which is mu, divided by the standard deviation of S, sample standard deviation over root n, square root of n, okay, which is, we can now put our numbers. As you know, I've listed them here already. I listed them here already. So all you gotta do is to plug them in. Okay. So let's plug them in. Here. So I'm gonna have S bar is 23450. Oh, excuse me. 23450 minus 24,000 divided by standard deviation, okay, which is 400, sample standard deviation 400 divided by square root of, and n is 10. Negative 4.35. Actually, negative 4.348131,783, but approximately it's negative 4.35. So let me write it down. Negative 4.35. So, okay, negative 4.35. So I'm gonna put it right here. And put this, I haven't even put the numbers in. Okay, let me put it right here. I got 23, okay, 450 minus 24,000 divided by standard deviation. Okay. All right. Standard deviation, which is here. Okay. Oh, excuse me. My mistake. I'm gonna put it right. Standard deviation of 400 by square root of 10. And we got the answer from the calculator as negative 4.35. So I copy this. Okay. And then paste it on our main workbook. I believe this is right here. No, it's not, that's not it. Our main workbook is right here. Okay. Now, again, we have done almost everything. We have done the calculation. We have done still the hypothesis, our alpha, our critical value. Now we got our T test. Get the result. Now it's time to make decision. Okay, remember the decision is based on critical value. And for critical value, is do the opposite of the p-value. For p-value, you reject no hypothesis when the answer for when the p-value is less than the alpha. But for critical value, you're using the traditional method or the critical value method, you reject null hypothesis when your answer is bigger than the critical value. So in this case, our critical value is 1.833. Okay, 1.833. Our calculated t value. Our calculated t value. Okay. Our calculated t value calculated. Okay, I did put it this way. Our calculated value. Calculated value equals how much? See, negative 4.35. Negative 4.35. So we remember this is we're using the absolute value of this. Negative sign is just to tell you that it's on the left side. Okay. So negative doesn't mean that it's less than. Just to tell you that it's on the left side. We're using direction. So we're going to be using the absolute value of that, which is absolute value, say, let me put negative 1.35, 4.35. The absolute value, I can put it this way. Is the black. The absolute value, you know how to get the absolute value. Okay. Okay, we have it right here. Okay. I'm gonna put it on the side. Equals 4.35. For your algebra class, you know that absolute value is always positive. So now we can compare them. 4.35 is bigger than this. So we reject null hypothesis. So reject the null hypothesis because the calculated value of 4.35 exceeds the critical value. Value of 1.833. So that's why you reject. So we can now make our decision. Conclusion. Now, remember, our critical value is 1.833. Our calculated value is negative 4.35, which the absolute value is 4.35. So it's bigger. We reject null hypothesis. So that means we are rejecting the claim, which means that this one is correct. The claim is not correct. So there is insufficient evidence. There's not enough evidence to support the director's claim, or I can say there is enough evidence to reject it. See, so there is enough evidence to reject the director's claim. Okay, that there is enough evidence. I'm going to make it to be the same size. I'm not able to reject the director's claim that was claiming that that the average salary of nurses, during that time is $24,000. So there is sufficient evidence that the average salary of nurses during the time under review is $24,000. So there is enough evidence. Or I can say there is insufficient evidence to support the claim. Okay. So insufficient evidence to support the claim, or there's enough evidence to reject the claim. They're basically saying the same thing. So that is it for hypothesis testing. Now you can practice this one, this type. Sometimes you might have a question like this where they didn't give you the mean and the standard deviation. So in that case, you have to find the mean and the standard deviation by yourself by using the formula I showed you at the beginning of the semester, or you can get them from Excel. Like this type. You can get this from type this number in Excel, use it to get your mean and the standard deviation, and then use it to solve the same thing I just did. Yeah. If you don't know how to, if you don't remember how to get the mean and standard deviation from Excel, I can show you. It's very easy. I have this page I opened. They say that this is a list of numbers, and that you want to get the mean of these numbers and the standard deviation. You just can type the mean, okay, and type the standard deviation. Okay. Deviation. Okay. Now, with that, you can just say mean is average. So put equal sign, always put equal sign. We want to do a calculation in Excel. Then type average. And it will pop up. Then double click on it. Then highlight, select the numbers. Then press the enter key. Gives you the mean right away. For the standard deviation, just do equal STDEV dot S, because this is a sample, and it pops out. Double click on it, select the numbers, press the enter key. See, now you can make them to be 2 decimal places. Highlight them. Then this is the where you choose decimal places. For decrease is right here. Yeah, 58.9 for the mean, and sample standard deviation is 5.1. And with that, you can now proceed for this type, follow the same method that we followed here, all the steps. Since now you have the mean and you have the standard deviation, and you get your answers. So here concludes our test of hypothesis. We're not going to do the other part, which is for proportion and for difference between two means, because time is so short. So next week we'll be looking at regression and correlation. Before we leave, does anybody have a question for me? If you have a question for me, you can ask now.
You post these notes?
Huh?
Can you post the notes?
I can't hear you.
Can you post the notes?
Oh yeah, sure. Now, Nadira, right? Can you hear me, Miss Nadira?
Yes, I'm here.
We're supposed to have a office hour on Tuesday, right?
Well, you had offered Saturday, but I'm not free Saturday. Can you do tomorrow?
I'm thinking all you need to know is just the Excel, right? How to use it. I'm thinking, why not if I can show you after the class is over now, because I'm not sure of tomorrow.
Okay.
All right. So what do you want to know, really?
Like
others, you can now log out if you want to log out. If you want to stay, you can stay, but class is over. So Nadira, I think there's another one, Mayo, right? There's something Mayo. Miss Mayo, are you here? No, not here. Okay, Nadira, what do you want to know?
So I can understand up to like question like step 5, and then I get completely lost on the Excel assignment.
Yeah, do you have an example? So I can show you an example. Do you have an example you want me to use?
Yeah, let's start with Excel assignment number 1, because I can't even get through that one.
This is assignment number 1.
Yes.
Okay. There are 2 ways you can do that. Let me see. I'll use an example. Let's say that we have a list of numbers. Let me see. I'll pull this out. I'll have, let me close some of these pages so we can have enough room.
Are you teaching this class in the summer?
No, not this summer, not summer. Yes, my next class will be in fall. So I want to close some pages so we can have enough room for this. So I'm gonna close this one. Okay. Now, what other page do I need to close? Okay, I'm gonna save this. Okay. I'm gonna close it. Give me 1 minute, let me check something here. Okay, everything is here. Okay, good, good. All right. The Excel assignment file is a 1. Let me show.
Yeah.
I think I have enough time to show you that one. Yes, 1. The other ones are really easy. Just follow and I have videos too that you can watch. Excel assignment 1. So I'm gonna use. Let me see what the question said, and I'll get an example to show you. Excel assignment 1. That's the one, right?
Huh?
That's the one we're talking about.
Yeah, so 1.
I want to share this. This is the one, right? It says
Yeah.
2 here, but it says 2 here, but actually it's 1. And this one is saying in this assignment, we use Excel to construct frequency tables. There are 2 parts to the assignment. So let me. So what we're having problem is it doing the frequency table? Is that the problem? Is that why we're having the problem doing the frequency table?
No, I can't do it after like step 6 or 7.
All right, let me use a different list of numbers. Let's see if I can generate some numbers. So you say they want you to find the frequency table.
It's fine. It's fine because when's the last day to submit assignments?
Oh, it's next week.
Yeah, it's fine because there's no way I'm gonna get through all these. I'm gonna just have to retake this class for a 3rd time.
Are you sure you've been doing class well in other class in the classwork? You're doing the classwork.
2, 3. This is my 3rd time doing this. I go to every class and still fail because of these stupid Excel assignments. I'm gonna have to just retake it in the summer because I don't have the time to get everyone done in a week, and I'm not gonna pass without doing them. So it's fine.
But you are doing the classwork and you're getting them correct, right?
Yeah, some of them it started getting harder towards the end of the semester, but half of the classworks I did pretty good on. Oh wait, all the classworks I did good on. I thought you were talking about homework. Classwork I do good on, but the classwork and Excel are 2 different things. Yeah, I use my notebook in class.
Yeah, the Excel assignment is not really that hard, Miss Nadira. I mean, if I show you one, and you can see that it's not really, because Excel do most of the work. Right? All you gotta do is to type in the numbers, right? You know. You see what I mean? I don't know if they do take this class. I don't know if they do it in summertime. I don't know really, but I do it spring and fall. Are you sure you don't want me to show you this, at least this one?
Yeah, you can go over this one.
Okay, let's see. Okay, let me some numbers. I'm gonna use these numbers here. Let me see. Raw data. Let me use this data to show you. I'm gonna copy this. Well, this one is not it's GPS prices. This is temperature. Let me use GPA or job openings. I'm looking for the right data. Okay. I can use this one. Okay. I'm gonna copy this, open a new Excel so that we have enough room to do this. Paste it. Okay, so that I can close the other one. Let me close this one. Okay, and then this is job. I think it's jobs, I believe. Give me 1 minute. I think it's jobs, whatever it is. I don't know what it is, but it's a list of numbers, and you're asked to get the frequency table for this. You're asked to find. I'll close all of these things so we can have enough room. I have so much open here. Okay. The Excel assignments. The question there was to, I'm doing the same thing they asked here, but I'm gonna use this. I mean, there's the different numbers to construct frequency tables. Okay, good. Now, we can now go there, and then this is the numbers we have now. Okay. Now, okay, it didn't tell us what what they call it. The assignment might tell you to use different give you the class suite. Here, you can just use any class suite. Let's use the class suite of let's see how to find a class suite. You can say that we have. I can arrange to make it easy for me. I can arrange this to be from smallest to largest. Okay, I can just do from smallest to largest. So I can go here, all this. So I can sort them, highlight all of them, sort them. So click sort from smallest to largest. Smallest to largest. Can you see where I click on?
Yeah, I know how to do that.
Huh?
I said yes, I know how to do that.
Okay. I click on the same, I sorted it out. So now we can now decide on the class width to use. Class to find the class width, the formula for finding the class width is the smallest value minus, the largest value minus the smallest value divided by the number of classes. Class width equals here the smallest value, maximum minus minimum divided by number of classes. Well, depending on the instruction they gave you given, So we have, let me see what they have in the assignment, basically. So we can just follow it from there. From the assignment, it says here, okay? It says highlight, right? Highlight in fit, okay? Highlight 8, okay? We highlighted it, so, and sort and filter from largest to smallest. We just did that here. See, we sorted it from smallest to largest, right? Okay, we sorted it. Now, next step, it says there was to, it says, in Excel, to count the number of values, click formulas option at the top, then click more function option, then choose the empty cell A31, calculate the number of data values. Number of data values, we don't need, let me see exactly if they need any particular class width. Okay, because number is n 28. Here, to get numbers, how many values it is, you can just put 1 here, right? Then we give them serial numbers, okay, +1, and then you can, double click here. It will give you how many numbers we have. we have 50 numbers. See, 50 numbers. So that's what it's trying to show you over there. Or otherwise, you can just do count. Excuse me. Okay. You can just do count. Okay, equals count. Okay, double click on it, then highlight it to give you how many numbers we have. Okay, enter key. See, give you the same thing, 50. So either you list the numbers, same numbers, or you can just do count to give it a count. So even though, because it is written on paper, the explanation becomes too much. See, all this thing that it was saying here, for the whole of this place, right? The whole of this place, from here, all the way to here. All you gotta do is to put equal sign, type count, double click, see the count is out, double click on it, highlight from here all the way to the last one, press the enter key, and that will give you the count. See, same thing. So I think because it's on paper, they have to explain the steps. So the explanation becomes too long. Am I right? Hello? Nadira, you still there?
Yeah, I'm here. I understand that step too. It'd be after this step is where I get lost.
Okay, after this step.
Yes.
Okay, let's see what they say next step then. The next step, what is it? Okay. Okay. So let's see the next step. Okay, let's see. I'm looking for the assignment. Okay, I've seen it. All right. The next step is to you may now use direct. Okay. Okay, it says find the range. Then divide the range by the number. Okay. What he's saying here is what I was about to explain here. Remember, I want to explain here class width, maximum minus minimum divided by number of classes. Okay. In this case, what it is saying here is it says the count is 29. To set up the group frequency, we need to compute the class width. We compute the class width by dividing the range by the number of classes and divide and then rounding off. So for the it told you here to use 6 classes. See, you see, then divide by 6 classes. So basically, it's trying to find the class width. It is telling you how to find the class width. So now, from then on, I won't be looking at D anymore because I think I know what it wants. So so from here, we have our count with 50. Remember, total. Our count is total. Okay, is 50. Now, the class width, I have the formula here. Let me just copy the formula and paste it on Excel so that we can go from there. Okay, I copy the formula. I'll take you to Excel. Okay. I'm going to paste it somewhere in Excel so that we can use it. I'm going to paste it here. Okay. Now the formula right here. I'm going to make it bold, make it big. Good. So now you have this. So let's find the class width now. So the first thing is to class width. Class width. I'm gonna make this bigger. Class width is, remember, it is maximum minus minimum divided by number of classes. The maximum is that's the range basically, equal to I will have maximum See? Type equal, then type max. Highlight this, all of this. All the way to the last one. Okay. Minus minimum, type MIN is out, sorry. It closes, minus, then put parentheses, then minimum, MIN. It shows up right here. Double click, highlight it again. Close it. Okay. Twice. Then divided by, remember you have how many parentheses? You have two opening parentheses, 1, 2. Okay, I have 2 here. Now let me put one more to balance it. It's not balanced. Divided by number of classes. It said to use 6 classes. So type 6 there. Okay, it gave me a wrong answer. Okay. Okay, don't worry. We get it. If this doesn't work, just put equal sign. Maximum number here is 125. And minimum is 7. So you gotta put parentheses, click on 125 minus 7. 7. Then close the parentheses. Divided by a number of classes. It says 6 classes, so put 6 there. I'll give you the 19.667. Usually we make it a whole number. Make it a whole number. So we can just reduce the decimal places. It's 20. 20 is the class width, 20. Now with this, we can now start a table. Class interval. For the class interval, we're gonna have minimum, then maximum. Okay. So for the minimum, the first one is 7. So you got to put 7 here. So the next one, you keep adding 20 to it, and you get the rest. So you got to do click on put equal sign, click on 7 plus 20. Then press the enter key. Then you can drag it down to 6th number. Say 1, 2, 3, 4, 5, 6. So we don't need this one, so you don't move this. For the minimum, the second number in the minimum is 27. That means the first number in the maximum is gonna be 28. Sorry, 26. You type it in, and then keep adding 20 again. Click on that, put equal sign, click on this plus 20. Enter key. Then, of course, you drag it down to it will be adding 20 to it, all of them. So that take care of this part. Then next is the frequency or midpoint. Midpoint is not this number plus this number divided by 2. So it equals you have click on 7 plus 26, close the parenthesis, divided by 2. Then press the enter key to give you the midpoint. Then you drag it down. It will calculate for the rest of them. See, the Excel do most of the work for you. Now then we have the frequency. Frequency, you can easily get it from here. From 7 to 26, how many numbers are between 7 to 26? You got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. You put 9. How many numbers are between 27 to 46? Okay. 27 we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them. You put 12. Nadira, you see there? Hello? Hello? Nadira?
Professor, I had a question
Yes, yes, sir.
while I left. I know how to do all of this. I just wanted to know, could you look at my email?
Who is talking now?
This is Bryce.
Yeah, I remember I told you to email, to either you upload it or
Yeah,
email it to me.
yeah, I did that. I been did that the day I got that email. It's a different email.
Okay. What happened? You
That-
can
that-
tell me.
that
You
was
can
all.
tell me now. Tell me now.
Oh, it was about missed homework assignments. My attendance is over at 80%.
So in the email you send me the homework you want me to put back for you?
I actually submitted the Excel assignment when you email me.
Mm-hmm.
I just wanted to know about past homework.
Okay. So what do you want to know now? You want to know if you passed it or
Make up past homework, yes.
you mean the homework, right?
Yes,
So
yes.
what you're gonna do? Let me check your attendance first.
Okay.
I had a question too.
Yeah, give me a minute. Let me see his attendance. This is Bryce, right?
Yeah.
Okay. Okay. Good. Now, what you're gonna do now is send me the email. Put the homeworks. I can open up to 4 homework, not test though.
Okay, no
homeworks.
test.
Uh,
Yes, just homework.
yeah.
So I can make them up?
Yes, you have a good attendance, so yes, you can. I can do up to 4 homework for you. Make it open 4 homework for you.
All right, thank you.
So you gotta look at the homework that you didn't do well,
Okay.
and then put it on the email. Remember, homework 1, they all have names.
Okay.
Yeah. All right, good.
All right, thank you.
You're welcome.
All right. Have a great day.
You too. Well, who else?
Me, I had a question. So
Who is speaking
basically,
now?
Benjamin is the one.
Oh, Benjamin.
talking.
Oh, I saw your email. I just haven't responded to that. You put the names of the homework, right?
Say that again.
Did you put the names of the homework that you want to be?
I said homework 1 and homework 2 from like the first week.
It's on the email. Is it on the, is it
No,
on
like
the
in the
email?
email I said though.
Huh?
In the email I said that.
Hold on. Yeah, Benjamin, who again? What's the last name?
Moore, Moore.
Okay, good. So, in fact, as a matter of fact,
Right there.
let me do it now. Let me do it now so that since you have already sent the email, right?
Yeah, I sent you an email. I was basically just asking you if I could redo homework 1 and 2 because it was from like the first week and I had basically misclicked. Like it's gonna sound dumb, but I basically had misclicked and it turned it in and I couldn't redo it. And I was just thinking like maybe if I asked you might let me redo it.
Can you see the screen?
Yeah, I see the screen.
This is you right here, right?
It just says business statistics on the screen.
Okay. Anyway, I'm gonna
What am I supposed to be looking at?
I'm gonna do it now. Let me more.
Yeah.
Okay. Okay.
When's the last day to turn in assignments? When's the last day to turn in assignments?
Next week, I'll assignment. I'll be able to give you that answer next week. But this one I'm about to open for you now. I need it done by 14th.
The 10th?
14th.
14th. Okay.
All
right.
The one I'm about to open for you now.
Okay. Thank you.
You're welcome. Okay. It says homework 1 and what again?
Homework 1 and homework 2.
And 2.
It's from like the first week.
Okay. Homework 1 and homework 2. So homework 1, yeah, 14th. Then homework 2, 14th. So I've opened it. You can check it now.
Okay. Thank you. I see it.
All right.
Thank you.
Welcome. All right, guys. I see you guys next week. Have a good night.
Wait, hello?
Adira.
Make sure you post the classwork.
Wait, Professor,
Yep.
I had a question as well.
Go ahead.
I had a question about the homework 5 probability theory. We had spoken over email about it, but I didn't clarify which assignment I was talking about, and I wanted to see if I could still make that up.
Well, homework 5.
Yeah, homework 5.
Let me look at who is speaking now.
Khalil Foster.
Foster. Okay, let me see. Let me look at your attendance. I'm not seeing this. Okay. Foster. Oh, 71%. So it doesn't get up to 80%. So did you send me email?
Yeah, we spoke about it in the email.
Are you
just
the
needed-
guy on sports?
Say again?
Are you the guy that was doing a sports or had an accident?
Say it one more time. I couldn't really hear you.
I mean, you told me something about it. I mean, was it why you missed it? I can't remember.
I think you said you would reopen it. You just needed to know which assignment I was talking about. I didn't clarify like the name of it.
Did I say to send me email?
Yeah, I sent you an email.
Okay. And I replied.
Yeah.
Okay. I mean, 70 is still good. Let me see. Yeah, 70 is still good. So I'm gonna open it. So homework 5, huh?
Yes, sir.
Manage student Foster. Khalil Foster, right?
Yeah.
Okay. I'm looking for. Yeah. I'm trying to get your students. He didn't say, okay, he didn't say. I don't know why he doesn't want to say, but I'm gonna do it now. Homework 5. Homework 5 is the one probability theory, right?
Yes, sir.
First, it doesn't say your name. I don't know why. Okay. Second time. 5. I'm trying to add it with your name, but for some reason it's not give me 1 minute. I'm gonna fix this.
Okay.
Okay. Poster. Oh, it's still having the old names. Okay, I think I got it now. Homework 5, huh? Poster.
Yes, sir. Homework 5, probability theory.
So now, okay, 14th. Get it done by 14th.
Thank you.
Welcome. All right, see you guys next week. I think I lost Miss Mayo.
Wait, Professor. Hello?
Yeah, I'm here. I'm sorry, Nadira. I'm not like Miss Nadira. Yeah, what can I do for you?
I have a concern about some of these absences.
Huh?
I had my trainer email you before about my concussion after my car accident. And the February 27th and February 20th, and also the March 20th. Those were supposed to be excused absences.
I think we talked about this in the class.
Yeah, but it's still showing up as I was missing those days.
Yeah, see, if you're not there, I can't mark you present if you're absent. So the only thing I can do for you if there is a makeup work you want to do.
Oh, got you.
You see what I mean?
Yes,
You're
sir.
not there, you're not there. Yeah, so I can't put you present, but I can, given because of the health situation, the accident, I can, give you some makeup work. What you're talking about classwork, right?
Yes, sir. There's classwork 5, 6, and 5, 6. I redid them. Classwork 14. I completed that.
So which
And
of the classwork are you missing now?
which classwork am I missing now? I did most of them. I did all of them actually.
I haven't just
believe-
graded them, right?
Yeah, you haven't
I'm
graded them.
I'm going to grade them. I'm just behind like grading.
Oh, got you.
Yeah, I'm going to grade them.
And also, could you open up the homework assignments?
Which one?
Dang, I'm missing a few of them.
I would say write them down, email it to me tonight so I mentioned about this the accident so I can just open it for you.
Yes, sir.
Remember, all of them have names. Homework 1, homework 2. So put the names.
Got you.
All right.
All right.
See you
Thank you.
guys. Miss Nadira, I think I miss her. I think she's gone. So
I'm here, but we can end it here for tonight.
I
Thank
was
you.
looking for you for all this before
I know it was I got these long nails on. It was hard for me to press the button, but
So anyway, but you understood where I stopped, though, right?
yes.
It's just that on paper, when they have to write it everything on paper, they explain it becomes too long, the explanation. So it's different from when you are doing it without looking at the paper.
Okay. I'm gonna try from the library's computer instead of my computer this
Okay.
week.
All right. You have a good night.
Yes, you too.